Data fans! I forgot I had to do a presentation in 2 days' time about agents and generative AI to an audience of department leaders, architects, and tech leads. They play with ChatGPT and GitHub Copilot, but they're not actively following the field. They vaguely heard about RAG and MCP and agents, but that's it. So I merged a set of Python GenAI demos to showcase what I think are the most important milestones from basic LLM calling to multi-agent systems. And it's interactive, so we were able to edit the prompt in real time to see the effects. That's not something I can do in this video, you should hire me for an interactive workshop instead. Anyway, here's the result after 2 days of work, and if you want to copy those demos after watching, stay tuned. What is agentic AI? I feel like if you ask this question to 3 different colleagues or people on social media, you will find 8 different definitions. Because everyone has to be agentic, every product, every company, everything has to have agentic features. And they will say they're agentic even if all they do is make an LLM call in the middle of their business processes, which is not something I would consider agentic. So here's my definition from my user point of view. That's how I sell agentic AI and LLMs to managers and architects and developers, and I want to do it through interactive Python demos because that makes it more interesting. There's a first definition that I like that comes from reinforcement learning. In reinforcement learning problems, you have an AI agent which has to complete tasks in an uncertain environment. And to solve those kind of problems, we usually split it into 3 components. You've got your environment in which the agent is acting in. You've got your set of actions, which are actions that your AI agent can take in this environment. And you got the rewards, which is feedback that your agent takes back from doing an action to know if it's going in the right or the wrong direction. If we take the example of customer service, you've got people that come to the AI agent by saying, hey, I've got my problem with my fridge, I don't know what to do, I'm very frustrated. And maybe the AI agent also reads from the environment that there were a lot of problems with fridges recently, and there are not a lot of human agents that can call people because they're already swamped by other issues, technical issues. Using all of those environmental reads, the AI agent then needs to decide what action to take. Now, this is a sub-problem from reinforcement learning that we call multi-armed bandit problem, where the agent has to choose, do I send do I send myself with a fridge problem to a new call, or do I send that person an email from a list of email templates? For example, I will send Fanil an email with a set of solutions to solve its fridge problem, and then I will wait for a reward. Maybe it's going to be Fanil has called back and said, nah, it doesn't work, or maybe inversely, Fanil is happy and in the customer service says, I am very happy with how you solve the problem. This is feedback that the AI agent will take into consideration to update its own policy using an algorithm, and to decide the next time Fanil or someone else calls with a fridge problem, the AI agent will decide, well, the email worked beforehand, there was positive feedback, I will send an email again, or maybe I will explore the action space a little bit and send that person to get a call from a human agent instead. And little by little, the AI agent is going to learn the best set of action to take regarding what's going on in the environment that it reads and the set of feedback that it got previously from other interactions. Reinforcement learning has a very structured way of solving the problems, which is totally blown away when you're working with large language models or LLMs. Because in an LLM, you give it an unstructured prompt, like extract the name of the user, the call reason, the phone number, and if it's a positive or negative sentiment from the following user query. Hello, my name is Fanil, I've got a problem, I'm unhappy, here's my phone number, please call me back. And when you submit this prompt to a large language model, it is going to generate text word by word, but it's very coherent text that is going to match with the conversation context. So here it generated, here's the breakdown of the user query. There's my username, Fanil, I'm calling for a problem with the internet connection. Here's my phone number. And my sentiment is very negative because I'm very frustrated. Now, I didn't want this indicated by frustrated, so I'm going to submit again. Generate. Oh, there you go. This second submission is better. Now it's just negative. And okay, maybe this topic has grown a little longer. But yeah, using this more unstructured way of solving problems for now, we unlock a whole new set of tasks. I can translate any foreign emails that I don't understand from Japan or India or France. I can summarize entire sets of reports and ask my LLM to make a summary of this report, or I can even rephrase my professional email to my manager to ask for more money. The thing is, from a purely developer perspective, I don't like parsing this markdown, and you have noticed that sometimes this sentiment is negative, but sometimes it's negative because I'm frustrated. So it's not very clean. Maybe I can do more prompt engineering where I say, and here for positive or negative, I really only want positive or negative. But anyway, I don't want to parse this markdown. I want the LLM to respond with some JSON, structured JSON. To solve this, I can provide an input schema, an output schema for how the LLM is going to generate an answer. For example, here my schema output, I want it to have a name, a phone number, a reason for a call, and a sentiment, and there's a description and a typing for each of those arguments. So for name, it's going to be a string with the name of the caller. My phone number is the phone number of the caller. A sentiment is the sentiment of the caller. It can be positive or negative only. And the call reason, I can also bring a set of predefined topics like internet issue, billing question, or technical support so that it doesn't try to generate or hallucinate, invent other flags or the categories. And now I will submit the LLM both the schema output and the user prompt. Hello, my name is Fanil. I'm still calling for a problem with my internet connection and I'm very unhappy about it. And the LLM is going to be forced to answer with JSON. As a Python developer, I know I can use this to take further actions in my code. Do you think I'm able to get the LLM to answer with functions to execute on my side and arguments depending on what's in the user prompt? I want the LLM to, when it sees this, to call a function called send report with my username, my phone number, and etc. So now what we can do is I write my functions like get current balance, which will get the balance for a person named Fanil, and a function named edit balance with the name and the amount I want to provide to the bank account of that person. Some description of the arguments and the description of the function. Don't read this one, I forgot to change it. And I'm going to input those function definitions, those function specifications to the LLM with the user prompt. How much money does Fanil have? Let me submit this, generate a response. And the LLM answers back, Fanil has 500 euros. Let me show you the CRM state, which is some Python variable that is on the backstage. So this is real Python working. And there's a CRM with Fanil as 500 euros and Alice as 1000 euros. So I can ask, how much does Alice have? I submit again. And Alice has 1000 euros. And you will see under it that the LLM, as the first thing it does is, okay, how much money does Alice have? It analyzes this user prompt and it answers back with a function. The function get current balance, the LLM understands it needs to use the get current balance on the argument Alice. And then the LLM sends back this information to my code, the Python code. And now I need to run this Python code on my side. I am the AI slave. I am the slave to the AI right now. And when I run this get current balance, I send back the result, the 1000, back to the LLM. And then the LLM is going to use this information to display the final result. Alice has 1000 euros. Now I want to add money to me. I just won 100,000 euros. Oh, I will say Fanil just won 1,000 euros. Yay! Let's submit this. Generating response. That's fantastic. I've updated Fanil's balance to 100,000 euros and 500 euros. And you see that the function, the LLM understood that I just won a lot of money. So I need to edit the balance. So it sends me back, please call the edit balance function with this amount and the name Fanil. My code runs it. So now my CRM states I've got a lot of money, 100,000, blah, blah, blah. I send back the result to the LLM and the LLM is like, yeah, look, I've updated its balance and now it's a lot of money. And now I can please check Fanil's accounts. And it understands again that, okay, let me run this function. So now you see that the LLM becomes a kind of orchestrator where it understands what functions to run and then asks me, the worker, to run those functions for the LLM, which is great because now you know that an LLM is able to call or define tools that it wants me to use for it. Providing a lot of context to an LLM is essential for it to choose the correct tool, the correct action, or respond with the correct information. And you may have heard of RAG or Retrieval Augmented Generation. Okay, it's running a bit, it's a little slow, let it cook. Provide external knowledge to LLMs with RAG. LLMs like Google's Gemini, they have a large context window. I think it's like 1 million tokens, which means in the prompt, you could put, I don't remember if it's one Harry Potter book or all of the Harry Potter books. You can put them in the context window of Gemini, or you can put them in the prompt. And then at the end, you can ask a question about what's the color of Harry Potter's cat. I think it doesn't have a cat, but anyway, Gemini should be able to answer this because it's able to analyze all of the Harry Potter book in the prompt to answer the question. You know that if you provide only this part of the information about Harry Potter to the LLM, it's going to answer correctly. So what we can do instead is we take all of the Harry Potter books, we split them into chunks, and then we embed them, we index them in a vector database. So each chunk of a book gets in a database, and then in my code I can ask what is Harry Potter's cat color. I am going to look in the vector database for all of the chunks of books, which ones are closest to the question, and then if I find such chunks, I will send them to the LLM so that it uses those chunks to answer the question. Let me show you how it looks like with a 300-page report, the Future of Jobs report to 2025 from the World Economic Forum. Now, this is from January 2025. So I think Google's Gemini cutoff is on January 2025. So this job report, normally Gemini has not seen this book or report in its training set. So it should not be able to remember anything about this job report. So I've indexed this into Google's RAG engine, and let me show. Here's my Google console. Here in my test data set, my test RAG data set, I've embedded and vectorized the WEF Future of Jobs Report 2025 in Google's RAG engine. And then I can go back to my Streamlit app and ask what are the top upcoming jobs given the jobs report. It's not going to load the 300 pages in the prompt. Instead, it's going to look for chunks about the top upcoming jobs in those 300 pages. And then it's going to answer you, here are the fastest growing jobs: big data, fintech, AI, data warehousing, and etc. And if I go below, you can see the chunks it has retrieved from the database. Like this is the first chunk, this is the second chunk, the third chunk, the fourth chunk, and the fifth chunk. It's only using those 5 chunks in the context. It's not using the whole book. And in those chunks, you will see, like, for example, here there's big data specialists, there are fintech engineers. You've got the answer is part of the chunks, and the LLM will be able to extract it to give the final answer. So RAG is one way of providing information from large sets of documentation back to the LLM so that it can use it to generate an answer or choose a function or a tool to run. And if the LLM wants to use a lot of different APIs, well, that's a set of functions to write from. And if another LLM wants to use them, maybe there's a different way of integrating an API or a tool or getting information from a RAG. And actually, it can get very complex to integrate multiple APIs, databases, information sources like SharePoint into multiple LLMs. So we want to standardize everything. Otherwise, we're going to get lost. And this is how Model Context Protocol was born. Model Context Protocol is a new open protocol, a new standard on how servers can provide information like API calls or function definitions to LLMs. So you've got the query and results on the left and the tools to call in the middle and a little bit of memory on the right. Those can all be managed by an MCP server. Here you can replace those three purple blocks with an MCP server. And your LLM will act as an MCP client, and when it needs information about documentation or tools, it recalls this MCP server instead of calling this API or this tool in a separate way. So this MCP server in the middle is like a new middleware between your backend layer and your LLM. I wrote my own MCP server for fun. Here, let me show it to you. An MCP server will provide three types of information. You've got your resources. For example, this is a resource for greeting, where if I ask for a greeting message for Fanil, it will provide a simple greeting message. In the resources, that's where you put all of your RAG information, your database information, or all of your SharePoint information. You can put it as a resource URL in the MCP server. I can provide tools through MCP servers. So like before, I've got my get balance tool, which gives back the balance for Fanil, or my edit balance, which is if I want to add money to Fanil, that's how it does. The MCP server will list all of those tools to the LLM or the MCP clients. And when the LLM says, I want to use the get balance tool, the MCP server will get back the name of the tool, and the MCP server will run that tool. So the MCP server will be the AI slave. So it will run the tool, it will connect with the API or the database, and then send back the result of get balance to the LLM so that the LLM can answer with the final results. And then you got a library of prompts. If I, as a user, I don't know how to use that MCP server, I can ask for a set of optimized prompts that I can use, like how do I ask about the balance of someone? If I don't know what prompt to use, the MCP server is going to answer with a prompt that I can use to connect with the tools and the resources, like, hey, Fanil, get the balance for Fanil, and then do something else. This is in the prompt library of the MCP server. Let's hide all of this, and again, how much money does Fanil have? The LLM connects to the MCP server. It will ask to run the get balance on the MCP server side. The MCP server will answer, and now the LLM will say, okay, I've got 1,000 euros. This has exploded in popularity so much that there's an MCP server for anything now. You can go on this awesome MCP list. You will find an MCP server to connect to Hostinger for LLMs for VMs. I think it's VMs, right? Is it VMs? I don't remember. Wait, I don't remember. But you can find, I think there's an MCP to connect to Microsoft Outlook, so you can check your mails through an MCP. So you can ask what are my latest emails, and the LLM will connect to Outlook through the MCP server and send back the emails. Like, and maybe there's one for SharePoint. I don't know. There's one for SharePoint. I think there are multiple ones for GitHub, so you can chat with your GitHub. Yeah, there's a MCP server for almost everything now. One of my favorite one is the Blender MCP. Here you can see I've got Cloud that talks with Blender. Let me hide this. On the left, you can see the chat, and I can chat with my Blender application. So I can ask to rotate the house, and the LLM is going to ask the MCP server, okay, can I use the tool to rotate the house? And the MCP server is going to rotate the house and send back information about the current status of the application. Or maybe it will even send an image of the house. Because, you know, when you're able to get all kinds of information from an MCP server, well, you do want to have more and more ways to analyze information from the LLM point of view. Whenever I ask to do something about green plants, for example, I don't know if I'm talking about a factory or a flower. But if I see it and if I smell it at the same time, if I'm mixing modalities, I have a richer understanding of what's happening. So if I smell a flower and I talk about green plants, I know we're talking about flowers. So let me talk to my LLM. Let's say microphone allow. Hello, I want to know what's in the fridge. Okay, so here's my audio snippet, and I'm going to put an image of the fridge. Here's the fridge. It's just a common fridge. And now, oh, I forgot to change my user prompt to use the audio to analyze the image. So here I'm a customer service assistant. Describe what you hear in the audio and see in the image content. And then drum roll. Okay, I hear distinct sound effects and someone that asks, hello, I want to know what's in the fridge. And then it's going to describe the image. Top shelf, middle shelf, it's a fridge, black mini, refrigerator, etc. We don't care. What you see is the LLM can both mix audio, video, sound, and user prompt to answer a question. So now you can even have your MCP server send back image as an array of bytes to the LLM, like the house from Blender, and it should be able to analyze this image and know this roof is not in red, so let's use UV mapping or new textures on this red block. I actually did 3D modeling years ago, and it was very long and very difficult. Our LLMs are getting better and better at understanding their environment, and they're getting more and more tools to use from to act on the environment. So now we want our LLMs to start getting better at planning and reasoning. And we got multiple LLMs like DeepSeek R1 or Gemini 2.5 that were trained with new perspectives. Because now we also provide those models with logic problems, with mathematical problems, with coding problems, with SQL problems. Those are problems where when the LLM answers something, it's easy to verify if the answer is right or wrong. For mathematical problem, I can build a small calculator to see if the final calculation answers the small problem. I can do the same for SQL or for coding problems. And so there's a way to provide a reward, an inner reward back to the LLM so that it knows if it answered the small problem correctly or not. When you train those LLMs with those little problems, it seems to be able to detect if it's right or wrong and to slowly plan how to solve a problem. It's going to have small steps, reasoning steps in the middle where it analyzes the problem and step by step comes to the answer. It's hard to call it true reasoning from my point of view. It's more like I solved so many little problems that I'm able to pick from multiple small problems to solve this big problem. It works at scale. If I submit this prompt back again, extract the name, user, call reason to hello, my name is Fanil, and I ask to see the reasoning steps. Here's again the answer, name of the user, phone number, and I'm very frustrated. If I look at the reasoning thoughts, you'll see, all right, here's how I approach this information extraction task. So it defines the problem first, it dissects the user prompt, and then Little by little, it will look for the information it needs. Okay, name of user. Okay, first sentence. Hello, my name is Fanil. Bingo! The phrase is my name is, so Fanil is my prime candidate. Confirmed. And you can see those small, I think, there's this bingo here. There's this done, I'm happy, it's done. And there's this, that's it. You can almost see the LLM talking to itself and sensing a kind of inner reward. Like, okay, I confirm this is the solution, that's it. It's not per se a reward like in the older reinforcement learning problems, but it's still a reward in the sense that it knows if it's going in the right or the wrong direction. And using those rewards, it's able to reason and plan all of the steps to answer the problem. This is where I would start calling this an agent. This LLM agent, it's able to read unstructured data from the environment, my user prompt, images, sounds, and etc. It's able to use this information to choose between tools from an MCP server or not, and those tools are actions on the environment. It can be rotating the house in Blender, and it can feed itself inner rewards, or maybe you can send back the reward from the action. You can send it back to the conversation of the LLM, because this can be multi-turn conversation, and it can use this as a reward to plan the next steps. So let me actually show you how it looks like on a bigger problem. Taking a little time to initialize, but then when it's warmed up, hello, how can I help you today? I will ask, what tools can you use to help me? So this agent has got two tools. It's got a BigQuery agent, so it's talking with another agent that has got 4 tools. It's got a tool to list tables in BigQuery and run SQL queries on BigQuery. And there's a search agent, which has a tool to do Google search. So I can search for the weather in Lyon. So now it knows, so first here, it understands that it needs to run the search agent tool. So it runs the tool does a Google research, sends back the info to the demo agents, and here it says the weather is 24 degrees Celsius and it's going to rain, which, by the way, is the case. It's raining right now. And yeah, there's a forecast. I didn't ask for forecast, but that's because I didn't do a lot of prompt engineering. I can now talk with my BigQuery tool. So what tables are in the BigQuery public data PyPy dataset. So this, I think, is a dataset where are stored the number of downloads for each Python package on the web. So here you see it runs the BigQuery agent. I didn't show the tools it uses, but there's a tool for listing the tables. That's what it calls. And the answer is the BigQuery dataset contains this table, and this table. Now let me describe the table file downloads, because I don't know what's in there. This is actually when I'm a little lazy. I use this BigQuery agent to ask questions about my SQL tables. And there you go. Okay, here's a description of the schema. Now it's slowly, not training, but it's slowly explaining my problems to the LLM, because now I can ask how many downloads of the streamlit package were made yesterday. Okay, drum rolls. Is it going to work? I hope so. Why do I say I hope so? This is still an LLM generating random words that should be about the context of the prompt. But you know, sometimes it hallucinates. It worked. So if I go on the BigQuery agents, I should be able to see the SQL here, the SQL query it runs. Select count from file downloads where project equals streamlit and partition date equals current date minus interval 1 day. So it should work. Okay, but there's no planning in there. I want to plan a harder problem. So let me ask it, search for free popular Python packages to build LLM apps and see how many downloads each of them had yesterday. Okay, let's see if it's able to answer this query. Now, if I was a good planner, I would sense that there's a search for free popular packages, so it will first call the search agent, and then it understands that I need to run the BigQuery tool for each result from the search agent. So this is, okay, I'm describing the workflow a lot here, but it should be able to translate this query here into a workflow of search agent, BigQuery, BigQuery, BigQuery. And here's it's pre-populating the answer. Fingers crossed. Okay, it detected that it needs to analyze Hugging Face transformers, LangChain, and Streamlit. I don't know why it did this beforehand, but here's the final answer. I found 3 popular Python packages, and here are the download counts for yesterday. 2 million, 2 million, and not 2 million. But you see that here my main agent is able to plan a workflow of one search and then 3 calls to BigQuery agent before providing the final information. It autonomously answered the question. That's agentic behavior here, because you read from the environment, you have a set of tools, and you're able to kind of use rewards to guide yourself in the correct direction. Then when you start doing this agentic AI with giving a set of tools and connecting to databases, and then watching this agent solve its own problems using its own set of rewards to reason and plan on the tools to use, you'll see that sometimes it gets lost. So this is where a lot of people tell you to break down an agent into multiple agents, like I just did. You don't want an agent with 1,000 tools, because you're not sure it will find the correct tool to use to solve a problem. If you give all of the API endpoints for Stripe, if you give them all as tools to the LLM and you say, send the current balance for a group of persons, it maybe won't be able to understand the nuance between an endpoint for one person and an endpoint for a group of people, and maybe it will try to recursively call one endpoint. So you want, instead of providing 1,000 tools, you may want to break down an agent into multiple agents, with each agent having a smaller set of tools and scope of responsibilities. Like for me, there was an agent for searching and an agent for BigQuery. There are now 2 different agents, and one agent can refer back to those 2 agents, like in this supervisor, this one here, supervisor to worker architecture here. Just know that there are multiple libraries for doing this. I'm using Google ADK for this, but there's also Agnew, there's LangGraph, there's CrewAI, and a lot of different ones. When you think about multi-agent systems, okay, you think about the number of agents, what happens if I have too many agents, what happens if an agent has too many tools, but also what happens in the communication process. Does one agent has to transfer all of the context to another agent, or do I have to provide smaller summary instead of too many tokens? What happens if an agent fails? Do I need to call another agent, or do I call the agent multiple times? If my search agent from before poisons the BigQuery agents with fake Python packages, it will break down the system, but I'm not sure if the BigQuery is failing or if the search agent is failing. There are many small problems around agentic systems. And a lot of companies actually, came to me and told me that, with fine-tuning, we can solve your problems. Because thanks to fine-tuning, if you provide all of your customer service traces, for example, of your successful conversations, then you can use this to fine-tune DeepSeek or Gemini to better think around your business problems. So this is all very, even I myself, I'm not very aware of how it works. But anyway, with all of those RAG, prompt engineering, MCP, and fine-tuning, you should be able to build agents that are able to plan around a large set of tools depending on user prompts and resources that are extracted from the server, the databases, the APIs, real-time APIs, and etc. And then depending on how they solve the problem, how they orchestrate around the problem, they sense if they're going in the right or wrong direction. Now you can see that LLM agents and reinforcement learning, they're very similar. If you say that tools are actions, user prompts and resources are context and environment, and then the reward is inner reasoning traces and the feedback into the conversation from what happened after the tool usage, well, it's kind of similar. And so whenever I'm in an AI consultancy project with other companies, I like to break down my tips into 3 different categories. My environment categories: what are better ways to provide context to LLMs, to agents? Do I use better documentation? Do I better document my APIs? Do I build LLM-friendly summaries of my websites or my documentation? Do I build an API portal to use as tools or to query for my agents? And then for my actions, I need to have people study those new orchestration frameworks or study how to build better MCP servers if we tell ourselves that MCP is the future. What's the impact of having multiple tools and multiple agents? How do I orchestrate? Do I do one linear workflow? Do I do deep research workflows where I can run tasks in parallel and summarize everything into one final agent? There are multiple ways to orchestrate and to define actions. And finally, in terms of rewards, how do I evaluate that the agent took the correct decisions, decided on the correct workflow? I need to build observability, so I need to store back all of the traces. Like if I go back to these events, I need to, I think that I can go back, trace. If I go on this, I need to be able to store all of those invocations, like I run this agent, I run this tool, and then this tool, and then this tool, and then this tool, and then this tool. I want to store this in a database to analyze it. So how do I store all of this? How do I analyze those traces? How do I prepare myself for fine-tuning or reinforcement learning, depending on how the agents autonomously built those workflows? Here there will be bullet points and next steps and actions to take and KPIs and etc. But that's for next time, you know. And yeah, that's where we are currently in terms of agentic AI. There's still a lot to do. There's still a lot of decisions to take between, do we let agents build workflows for us, or do we provide workflows to agents to run? There's a lot of balance to find here. Those are resources that one can use. I need to complete this and then push it to GitHub. If you watch this as a developer, you may watch this next video, because that's where I explain how I built this Streamlit app with all of those small demos and this Google Agent ADK demo. Otherwise, I'll see you around. Bye!